Super strength, super speed, and super endurance are all already possible. Biosensors, high-tech materials, voice control, and even mind control are already available. So when will we see a full-fledged Iron Man suit? And is it even possible to create one? Today, exosuits are not full-fledged robots, but devices that work with the user to enhance their strength and performance. But industry experts expect exoskeletons to bring more than just super strength to the body in the coming years. Tony Stark's suit, for example, allows him to fly, shoot, and protects him from outside influences, but it also controls his health and the temperature inside the suit, heals him, and even allows him to handle his body's natural needs. Most of these systems already do exist. Today, there's already amazing inventions, from military exoskeletons to giant exosuits for sports and entertainment to devices that help paralyzed people walk and control robotic limbs with the power of thought. Watch the top of the coolest exoskeletons from around the world in today's one episode. The exosuit became a reality in the 60s of the 20th century, when General Electric conducted research and development in the field of human augmentation, that is, its capabilities. With funds from the military, the company created the Heart of Man device. Unfortunately, it was too heavy at around 680 kilograms, and the project was shut down. The first exoskeletons to aid in walking were created in the late 1960s at the Mihailo Pupin Institute in Serbia and in the early 1970s at the University of Wisconsin in Madison in the US. But the military didn't stop there and returned to developing exoskeletons in 2000. Then DARPA funded two development teams. One was a group of engineers from the University of California at Berkeley, which eventually created BLEEX, or Berkeley Lower Extremity Exoskeleton, robotic legs for $50 million. The device has a built-in power supply and hydraulically actuated joints, two at the hip and one at each ankle and knee. Later, the development was transferred to Lockheed Martin, where it became known as Human Universal Load Carrier, or HULK. The titanium exoskeleton can carry 90 kilograms of weight, and there's no joystick or control mechanism. Instead, sensors detect movement and with the help of an onboard microcomputer, make the suit move to the beat of the body. The second group to receive DARPA money was the research company Sarcos. It developed the XOS-2 robotic suit, which uses high-pressure hydraulics allowing the wearer to lift heavy objects at a ratio of 17:1, i.e. increasing human strength by 17 times. Soldiers in the suit can reportedly move almost unrestrained. The company has recently brought its device to another level where it can be sold and used for military commercial purposes. The Guardian XO, an electronically powered exoskeleton with 24 degrees of freedom, can be put on in just 30 seconds, and then you can lift boxes weighing up to 90 kilograms for 2 hours without fatiguing. But that's not what makes it interesting. It is, in fact, a full-fledged robot that stands and can move itself under human control. By the way, Sarcos has another exoskeleton that looks even more impressive. This is the Guardiam GT. It's not exactly an exoskeleton, but in fact, the two robotic arms are an extension of the operator's arms, only much stronger. The tele-operated robot can lift up to 450 kilograms with each arm and do precision work such as welding. A tracked base enables the Guardiam GT to move, albeit not quickly, at 6.5 kilometers per hour. If the operator doesn't stand alone but was placed in the center of a structure, it would be a good cosplay of Dr. Octopus, wouldn't you agree? Another contender for the Dr. Octopus costume is Neo creation from Panasonic-owned Atoun. The suit is designed to help construction workers and rescuers clear debris. The network believes it can be a direct successor to the Caterpillar P5000 workloader from the 1986 movie Aliens. It's a pity that no commercial applications for these suits have been invented so far, nor have they managed to interest construction and rescue workers, yet. But there's even cooler exoskeletons. For example, the Prosthesis sports racing exoskeleton from Exosapien Technologies is more than 4 meters high. The machine is human-controlled and requires some training. Based on the movements of the user's arms, legs, and feet, the prosthesis can reach speeds of up to 32 kilometers per hour and jump up 3 meters, powered by a lithium-ion battery. Artificial intelligence helps the exoskeleton interpret the user's movements correctly. You can ride the prosthesis for 2 hours, which is impressive considering the weight of the construction is more than 3 tons. The developers hope to be able to run races on these machines as a separate sport, and it should be said that it looks incredibly cool, and the speed can compensate for difficult terrain. But by the way, it can be rented and raced in the will for only $10,000 per hour. Another impressive exoskeleton for entertainment is the Arrive from Skeletonics. The 3.3-meter tall suit has no battery but uses kinetic energy of the wearer's movements to mimic his gestures. As stated on their website, thanks to the fusion of mechanics and electronics, the machine's limbs can move just like a human. Considering that Arrive is designed solely for entertainment, it's all done very well. Let us know in the comments, would you walk down the street wearing this? Still, for the most part, exoskeletons are useful. For example, Atoun's Coma is a small power suit designed to help you carry weight. The original transforming design allows you to move on straight and sloping terrains as well as stairs. In a straight line, you can ride in buggy mode, and through rough terrain and stairs, you can walk in two-legged robot mode. Additionally, Coma is equipped with a built-in camera and artificial intelligence so it can safely avoid potential obstacles in its path. Cyberdyne's HAL Rehabilitation Exoskeleton combines a futuristic design with almost fantastic functionality. The suit is used by patients who suffer from spinal cord injuries, cerebrovascular disease, craniocerebral injuries, and other neuromuscular diseases or injuries. Brain signals to the muscles are picked up by sensors on the legs, which relay the information to the HAL, which in turn helps the user walk by simply thinking about walking. The company also has a suit for medical workers to make it easy for them to carry patients. The idea of controlling exoskeletons with the power of thought was further developed by scientists from the University of Grenoble and Clinitech Biomedical Research Center. They implanted two sensors into a fully paralyzed patient below the shoulders to record and convert brainwaves, transmitting movement commands. The man then spent 2 years training in a virtual reality environment, moving his digital limbs while deep learning AI monitored his brainwaves, trying to match specific signals to his arms and leg movements. Then, a suit was put on the patient and the software successfully converted the brainwaves into machine-understandable commands. The man was not able to move his arms, but also walk 145 meters. Now the developers are working on making the exosuit work without the suspension system. There are other exosuits that help paralyzed people walk, and by the way, one of the best lower limb exoskeletons was developed in Russia. The Exo-Athlete company produces devices for medical and social rehabilitation, which speed up the rehabilitation process and improve the quality of life for patients with locomotor disorders, including spinal cord injuries, multiple sclerosis, and the effects of strokes and cerebral palsy. We've talked about them in detail, and you can find that episode right here in the tip. Exoskeletons to help workers in factories and the elderly on walks are made possible by companies like Honda, Ford, and Samsung. They're all aimed at relieving the stress on joints, mostly the lower back, knees, or elbows. Something similar was tested by firefighters and medics in Singapore. The Operon exoskeleton is powered by two 7-liter compressed air cylinders that allow firefighters to ascend and descend 3 times from the 12th floor with 40 kilograms of equipment. The suit itself weighs no more than 3 kilograms and has a quick release mechanism so it can be thrown off if something goes wrong. The developers report that the robotic suit itself determines when and which joint needs to be supported. Exoskeletons empower humans and give them more strength and endurance. Although we're still a long way from creating a real Iron Man suit, we should not forget that Tony Stark was not a superhero, but a genius engineer. And that means everything is in our hands. Subscribe to the Pro Robot channel, like this video, and don't miss any new episodes from the world of high tech. And if you want to be the first to know about latest tech as it drops, follow us in our Instagram community, Pro Robots.